Hey everyone, today we're going to dig into a question that sounds simple on the surface, but is actually wrapped up in a ton of confusion. What is software engineering, really?
If you're a software engineer and you go to a party, this is the first thing you hear. Oh, so you're a coder? You write code? And look, it's a fair assumption, but it's like asking a master architect if they spend all day mixing cement. It's part of the job, sure, but it completely misses the big picture.
And that really gets to the core of it, right here. The myth is that software engineering is just about hammering out code. But the reality? It's a formal, systematic engineering discipline. The whole point isn't just to build something that works for a demo tomorrow. It's to create software that's reliable, that can grow, and that someone can actually maintain years from now without pulling all their hair out.
Okay, so let's really dive into that question then. What is the actual day-to-day difference between just being a coder and being a software engineer?
The best way to picture this is with an iceberg. Seriously. The code itself, the part that you can actually see and point to, that's just the teeny little tip poking out of the ocean. All the real work, the massive, critical foundation that keeps the whole thing from falling apart, that's all hidden under the water.
So let's take a look under the surface. What exactly makes up that giant, unseen part of the iceberg? What is all this stuff that engineers are doing before a single line of code gets written and long after it's been released? It's this whole structured process, and it's called the Software Development Lifecycle, or SDLC. It always starts with requirements, figuring out what problem we're actually trying to solve. Then you move to design, which is like drawing up the architectural blueprints. And then, only after all of that, do you get to implementation, which is the coding. After that, you've still got rigorous testing, deployment, and maybe the most important part, the ongoing maintenance and updates. So you see, the coding is just one step in a much, much longer journey. Let's go back to that house building analogy because it's perfect. A coder might be an absolute master at operating the cement mixer, a critical skill for sure, but the software engineer, they're the architect, drawing the blueprints, the project manager coordinating all the different construction crews, and the building inspector making sure the foundation is solid so the house doesn't collapse in a storm. It's the whole shebang. So what happens when you ignore all that engineering stuff and just focus on the code? Oh, it gets messy. And if you've ever worked on a chaotic project, you know exactly what this feels like. The code becomes a tangled mess. There's no documentation, so fixing a simple bug is total guesswork. Every time you push an update, it feels like you're defusing a bomb. And trying to add one new feature feels like walking through a minefield. It's pure chaos.
And this is the key takeaway. When a project falls into that kind of chaos, the problem usually isn't that the people can't code. It's a lack of engineering thinking. It's about not having that structured, systematic, forward-looking approach to building something that's meant to last.
So how do you get that thinking? How does an entire industry agree on what good engineering even looks like? Well, believe it or not, there's actually an official guidebook for the whole profession. And that guidebook goes by a single, kind of nerdy-sounding acronym, SWBOK. You probably haven't heard of it, but you've definitely used software that was built using its principles. Its importance is massive. SWBOK stands for the Software Engineering Body of Knowledge. It's this comprehensive guide put out by the IEEE Computer Society. They're one of the big global organizations that set standards for technology. And its whole purpose is to summarize all the generally accepted, agreed-upon knowledge and best practices for being a professional software engineer. It's basically the official playbook. And when I say comprehensive, I mean it. SWBOK covers 18 different knowledge areas, which just shows you how deep this field goes. We're just showing a few here. You've got the requirements and design we talked about, but also critical areas like how to architect the whole system, how to build in security from the start, and how to measure quality. It's the A to Z framework for building good software. So why does having a guide like SWBOK matter so much? What's the big deal? Well, it's what helps transform software development from just a skilled craft into a legitimate, recognized profession. The impact is huge, and it touches everyone. For engineers actually doing the work, it's a shared roadmap. For companies, it helps them standardize how they build things. For universities and students, it forms the basis of their curriculum. It even helps policymakers and professional groups figure out the rules for things like certifications and licenses.
And this right here is the bottom line. Having a shared core body of knowledge is what separates a real engineering discipline from just a collection of talented individuals. It's the foundation that allows for things like accredited university programs and professional licenses, which all work to guarantee a certain level of quality and reliability for everyone.
But you might hear that phrase generally accepted and think, that sounds a little vague, right? Well, the guide itself gives a fantastic practical definition. It's the stuff you should know to pass a professional licensing exam after you've been working in the field for 4 years. So this isn't just abstract theory. It's proven, real-world knowledge that's expected of a professional.
So let's end on this thought. Think about all the software that runs your life, your banking app, the systems in your car, the tools you use for work. The next time you use a piece of software that is just solid, that works flawlessly, that feels reliable, ask yourself, was this built by a coder or was it built by an engineer? Because now you know there's a world of difference.